All right, let's get right into it. The entire world of artificial intelligence is literally built on silicon. And right now, there is a massive, high-stakes war being fought over who gets to build the chips that power our future. This is a true battle of titans, and believe me, the prize is nothing less than complete technological supremacy.
You know, if you want to grasp the sheer scale of this AI arms race, it really just starts with one number: $3 million. That's what it costs for a single server rack, just one, packed with Nvidia's latest chips. And get this, they're shipping 1,000 of these every single week. It's just staggering.
And that brings us, of course, to the current king of this entire landscape, Nvidia. A company that, kind of rocketed from the world of video games to become the absolute, undisputed heart of the generative AI revolution.
So how in the world did a gaming chip become the engine of AI? Well, it all comes down to something called parallel processing. See, GPUs were first designed to render these super complex game graphics by calculating millions of pixels all at the same time. Then in 2012, we had AI's Big Bang moment. A few researchers figured out they could basically hack this parallel power for their neural networks. And boom, that unlocked incredible performance and made GPUs the go-to workhorse for both training and running AI models.
Here's the fundamental difference in how these chips actually think. A CPU, that's the brain of your regular computer, it has a few really powerful cores that just tackle tasks one after another, sequentially. A GPU, though, is a specialist. It's got thousands of smaller cores that can perform just countless mathematical operations all at the same time. And for AI, which is all about crunching these massive data sets at once, well, that is the perfect architecture.
But here's the thing, it's not just about the hardware. Nvidia's real dominance is cemented by its software platform called CUDA. This creates this incredibly powerful developer ecosystem that is just so difficult for competitors to break into. They haven't just built a chip, they've built a fortress around it.
But, as we all know, a king's throne is never truly safe. The biggest names in tech, I'm talking Google, Amazon, Meta, they are now designing their very own custom chips, and they are mounting a serious challenge to Nvidia's rule.
So, what's their weapon of choice? It's something called an ASIC. That stands for Application-Specific Integrated Circuit. Basically, this is a chip that's designed from the ground up to do one thing and one thing only. Once it's carved into silicon, its job is set in stone. But it performs that single job with absolutely incredible efficiency.
Here's a great way to think about it. An Nvidia GPU is kind of like a Swiss Army knife. It's super versatile and good at a whole range of AI tasks. An ASIC, on the other hand, is like a bottle opener. It's not going to help you cut anything, but it will open a bottle perfectly, every single time. Now this all comes down to a massive strategic trade-off. Yeah, designing your own ASIC costs hundreds of millions of dollars and takes world-class expertise. But for these tech giants operating at a scale we can barely imagine, the payoff is huge. They get chips that are cheaper to run, potentially way faster, and this is the big one, it breaks their dependence on a single supplier. So this isn't just about cost, this is about controlling their own destiny in an AI-first world.
And just look at this lineup. It's a literal who's who of big tech. Google was really the first with its Tensor Processing Unit, or TPU. Amazon has Trainium. Meta, Microsoft, even OpenAI are all jumping in the game, each building custom silicon to power their own massive AI ambitions.
And these aren't just little science projects. This quote from Amazon Web Services claims their custom Trainium chips offer 30 to 40% better price performance than other options. I mean, those are real-world savings that directly impact the cost of running AI services for everyone.
Okay, but this battle isn't just being fought in these massive, power-hungry data centers. It's also happening on a much smaller scale, right inside the devices we use every single day.
Seriously, have you ever stopped to think about where you personally interact with these specialized chips? The answer, well, it might actually surprise you.
They're already everywhere. It's called Edge AI, where the processing happens right on your device instead of in the cloud. It's in your phone's camera, your laptop, your car's safety systems, and yeah, even your smartwatch.
The key player here is the NPU, or Neural Processing Unit. It's this tiny, dedicated AI accelerator built right into your device's main processor. Running AI locally means your phone can instantly enhance a photo the moment you take it, or translate a conversation in real time without sending anything to the cloud. It's faster, it's more efficient, and this is huge. It keeps your personal data on your device, a massive win for privacy.
Okay, so we've got Nvidia building its GPUs, and we have the tech giants designing their own custom ASICs. But there's this really fascinating and critical piece of the puzzle we haven't touched on yet. Who physically makes all these different chips?
And this is really the twist in the story. All of these fierce competitors, these multi-trillion-dollar rivals fighting tooth and nail for AI dominance, almost all of them have to rely on a single company to actually build their most advanced designs.
And that company is TSMC, the Taiwan Semiconductor Manufacturing Company. You could call them the foundry for the entire AI revolution. They are the ones turning the blueprints from pretty much everyone, Nvidia, their competitors, and all the tech giants, into physical silicon. This incredible concentration of manufacturing in Taiwan has, you guessed it, created a new geopolitical flashpoint. In response, the U.S. is pushing hard to bring manufacturing back home with something called the CHIPS Act, funding brand new factories in places like Arizona. Meanwhile, China is racing to build its own domestic capabilities, but it's being hampered by export controls on the most advanced equipment.
So when you pull back, you see this complex battle is being fought on multiple fronts at once. So where does all this leave us? Let's try to connect the dots and see the real state of the war for AI's silicon throne. All right, here's the spade of play. First, Nvidia is still the clear leader, protected by its powerful hardware and that all-important software moat. Second, the tech giants are chipping away at that lead with their custom ASICs to gain control and slash their costs. Third, the war is expanding from the cloud down to the edge, to the devices in your pocket. And finally, all of it, every last bit, hinges on a fragile global supply chain and the monumental challenge of securing enough energy to power it all.
The market for AI hardware is just exploding. It's growing at an incredible rate, and new challengers are popping up all the time. Now, Nvidia has absolutely earned its crown, but in the world of technology, every king is just one innovation away from becoming history. The real question isn't if the throne will be challenged, but who's going to be the one to finally take it.